In this video, I'll explain the concept of measures of central tendency. First, let us see what is central tendency, why we need central tendency. Then later, we will list out what are the different measures of central tendency. So once you have done with the classification and tabulation of data, for the purpose of further analysis, we require a very important tool which is called as a single average value that represents the entire mass of the data. That single average value is one figure which gives you the summary of a distribution. That means if you have the classified and the tabulated data, to get more analysis about the data, we need a single representation of the data. That single representation is given by the central tendency. It gives a value around which the distribution is concentrated. So hence it is called as measure of central tendency. It is the center value of the distribution. Once you get that center value in the distribution, then we can use that one particular value to get the inferences about the data. So that is why it is called as measure of central tendency, and this is the purpose why we need central tendency. Calculation of central tendency condenses a distribution into a single value that is supposed to represent the distribution, which helps for individual assessment as well as in comparison with another distribution. This is the importance of finding the center value. For example, to compare the performance of two classes, we can compare the average scores in the same test given to these two classes. So, test has different subjects, and each student will obtain different marks in different subject. So we find out the average of each student, then we will be finding out the average of the entire class. So center value is average here. That average will help you to compare the performance of two classes. Based on those two averages, you can get analysis about the given data. Now, there are different measures to calculate the central tendency. They are mean, median, and mode. These are the three important measures of central tendency. Under mean, you have arithmetic mean, geometric mean, and harmonic mean. These are three different measures to calculate the central tendency. Let us see these measures one by one. So, before learning the measures of central tendency, first you have to learn different types of data. So, types of data. So, there are basically two types of data. One is ungrouped data, and another one is grouped data. Ungrouped data and grouped data. Under this ungrouped data, again you can have here discrete data, discrete without frequencies, and here discrete data with the frequencies. Discrete data with the frequencies. That means it is a frequency distributed data. Here it is just a raw data where the frequencies are not given. So discrete data means here data points are whole numbers. For example, when you have to find out the number of pages in a book, then we have 1, 2, 3, 4, and so on. It takes only whole number as its value. You don't have number of pages as 1.5, 2.5, and those values are not taken by that variable. So such data is called as discrete data. Raw data in the sense your frequencies are not given, just the data points are given. Discrete data with the frequency distribution means here along with the data points, when you have huge number of items in a given data, then we can condense that data with the help of frequencies. We call that as a frequency distributed data. So, for example, suppose you have unit test marks of 100 students, then you can condense that data with the help of frequencies. So, there may be repetitions of data values. Those repetitions are counted as a frequency. Then we call it as discrete data with the frequency distribution. That comes under ungrouped data. Grouped data means here the data points are grouped in the form of a class intervals. That is, when you have continuous variable, then you will get a grouped data for that continuous variable. You will have the class intervals as a data value range 0 to 10, 10 to 20, 20 to 30, that way. So then we call such data as grouped data. Then you have frequencies corresponding to those class intervals. Such data is called as grouped data. See, for example, when you are measuring heights of students, the height of a student need not take the whole number always, it takes fractional value as well. So in that case, if you write 0 to 10, that means any real value in between 0 to 10 will be included in that class interval, and the corresponding frequencies will be included in that particular class interval. So these are the two basic types of data: ungrouped data and grouped data. Under ungrouped data you have discrete without frequencies, and here discrete data with the frequencies. Under grouped data, only one category, that is continuous data, which is here you have continuous data which involves class intervals. Now I'll explain the first measure of central tendency, that is arithmetic mean. So the arithmetic mean of discrete data without frequency distribution is given by x bar, it is denoted as x bar, summation of I is equal to 1 to n divided by n. That means sum of all observations divided by number of observations. If you have discrete data with the frequencies, discrete data with frequency, in that case, mean is given by summation of fi into xi, I is equal to 1 to n divided by summation of fi, I equal to 1 to n. Here it is the product of frequency and the data point. Then take the sum of this divided by the sum of frequencies. The sum of frequencies can be denoted as capital N. So I can write it as summation fi xi divided by capital N, where capital N is the sum of all frequencies. So let us take one example. See here, calculate mean of the weights of 5 students. The weights are given here: 54, 56, 70, 45, 50. This is given in kgs. So there are 5 students, the weights of 5 students given here. So first to look at the data, it is discrete data. All data values are whole numbers and discrete without frequencies. Hence x bar mean equal to sum of all observations, 56 plus 70 plus 45 plus 50 divided by total. There are 5 observations. So number of observations is 5. When you take the sum of all this, you will get 275 divided by 5, which is equal to 55. Therefore, the average weight of 5 students equal to 55. This is the central value of the given data. Now one more problem. Calculate arithmetic mean. Calculate arithmetic mean for the following data. So the data is xf 20, 30, 40, 5, 6, 4. See here, this is the given data. First, identify the type of data. So the data type is discrete here because whole number values are given and no class intervals. So it is a discrete data, and frequencies are given. So it is discrete data with the frequencies. Therefore, I have to make use of this formula to calculate the arithmetic mean. So x bar equal to, the formula is summation of fi xi, I equal to 1 to n divided by the sum of frequencies. First you have to write a table where it contains the data value xi, then the frequency fi, then I want the another column xi fi. So here xi 20, 30, 40, then fi given 5, 6, 4. So take the product of these two. 25 is 100, 36 is 180, then 44 is 160. I need sum of xi fi, then I need sum of fi. This is capital N equal to 15. Then the summation of xi fi, when you add up all these values, you will get 440. Therefore, mean equal to x bar equal to 440 divided by 15. So, x bar equal to 29.3. So the entire sample is represented by a single average value, which is nothing but 29.3. This is how we find out the arithmetic mean for discrete data with the frequencies and without frequencies. Now take up one more problem. Calculate arithmetic mean for the following data. This is the given data. Now look at the data and identify its type, class interval and frequency given. Therefore, this is continuous data or grouped data because class interval is given. Hence, we have class interval here. Then we have frequency. Okay. Class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Frequency is given 3, 5, 7, 9 and 4. For continuous data, always frequencies will be given. Now, to apply that formula, no separate formula here, same formula, fi xi divided by capital N I equal to 1 to n. This is the formula for mean. Now, you have to find out fi into xi. What is xi? So, class interval is given. Xi is nothing but the midpoint of the class interval. Now, how to get the midpoint of class interval? Add these two endpoints, divide it by 2. So 0 plus 10 by 2, which gives you 10 by 2, which is a 5. Similarly, 10 plus 20 by 2, 30 by 2, which is 15. Similar, next 25, next 35, next 45. This gives you xi. This is your fi. Now you can calculate fi into xi. So 5 3 is a 15. Here 15 5 is a 75. Then 25 7 is a 175. 35 9 is a 315 and 45 4s are 180. Now I need sum of fixi, then I need the sum of frequencies. Capital N equal to, when you add all these values, you will get 28. When you add all these values, it is equal to 760. So therefore, substitute in this formula 760 divided by 28, that gives you mean equal to 27.143. This is how we calculate the arithmetic mean for the group data. Now, another measure of central tendency is median. Let us see how to find median for ungrouped data and for grouped data. Now, it is for ungrouped data and without frequencies, that is discrete data without frequencies. Without frequencies. Here, the formula is MD median equal to n plus 1 by tooth observation if n is odd. If you have odd number of observations in the given data, then n plus 1 by tooth observation if n is odd, and MD equal to n by tooth plus n by 2 plus 1th observation divided by 2. That is mean of n by 2 and n by 2 plus 1th observation. This is in the case when n is even. So this is the formula to calculate the median, and before finding the median, first thing you have to do is arrange the given data, either in ascending or descending order. This you should not forget. This is the first step you have to do before applying the formula. Whenever you are finding median for discrete data without frequencies, arrange the data either in ascending or descending order. Then apply the formula based on whether number of observations is odd or even. Now consider examples. Calculate median calculate median for the following data. Data is 64378. This is discrete data without frequencies. So first step is arrange data in ascending or descending order. I am going to arrange it in the ascending order, increasing order. So 3, 4, 6, 7, 8. How many observations you have? N equal to 5, which is odd. Therefore, median equal to n plus 1 by 2th observation, 5 plus 1, 6 by 2. So, third observation. What is the value of third observation in this? 1, 2, 3. So 6. So median of this data equal to 6. Similarly, calculate median for this data 7, 8, 9, 3, 4, 10. This is the given data. First arrange the data in the ascending or descending order. I'll arrange here it in the ascending order. 3, 4, then 7, 8, 9, 10. So how many observations you have? N equal to 6, which is even. So in the case of even number of observations, you have to find median as MD equal to the mean of n by 2 and n by 2 plus 1th observation. N by 2 means mean of third observation plus next observation is fourth observation divided by 2. 6 by 2 gives you 3. So third observation and next observation will be fourth observation divided by 2 because mean of these two observations. What is the third observation in the arranged data? It is 7 plus 8 divided by 2. So which is equal to 15 by 2. So 7.5. The median for the given data is 7.5. Now let's see how to find out median for ungrouped data with the frequencies, that is discrete data with the frequencies. So it is given by median equal to value of the variable corresponding to n by 2 cumulative frequency. N means total frequencies, n by 2 cumulative frequency. Let us see what is cumulative frequency, how to find it out, and then how to find the median for the discrete data with the frequencies. So here this is the data given with the frequencies. So X, F, 20, 40, 60, 80. Frequencies 7, 5, 4, 3. Now you have to find out cumulative frequency. CF means cumulative frequency. It is less than type. There is one more which is greater than type. Here I am finding less than type frequency. So cumulative frequency is obtained by adding its next frequency to the previous frequency, that is 7 plus, here first frequency is 7, next frequency is 7 plus 5, 12. Then that means number of observations less than 27, number of observations less than 40 is 7 plus 5, 12. Then number of observations less than 60 means all these will count, 7 plus 5 plus 4, so that gives you 16. Then number of observations less than 80 means all these will count, so 16 plus 3, that is 19. So capital N equal to 19. The sum of observations is equal to 19. That is cumulative frequency. So find last frequency should be equal to the total frequency. So now you have to find out MD equal to value of variable corresponding to n by 2th cumulative frequency. Observation corresponding to n by 2th cumulative frequency. So first let us find out what is the value of n by 2. 19 by 2, which is equal to 9.5. Now observe where this value 9.5 comes under this cumulative frequency column. You can see nowhere this value 9.5. So 9.5 is not among the cumulative frequency. So you have to take its next cumulative frequency, that is 12. Okay, because up to 7 means from any value to 7 that comes within this. Then next up to 12 here in the next section. Therefore you have to consider its next cumulative frequency. Now see the observation against this cumulative frequency, which is 40. Hence median equal to 40. This is how we calculate the median for discrete data with the frequencies. Now, how to find median for group data or data with class intervals or continuous data. So, MD equal to L plus N by 2 minus C by F into H. These are the explanation for the terms. L means lower limit of median class. N means total of frequencies. C is the cumulative frequency preceding median class, just preceding the median class. F is the frequency of median class. H is the width of the median class. Median class means how to find the median class. Median class means class in which n by tooth observation falls under cumulative frequency. You have to find out the value of n by 2 and check it in the cumulative frequency column, and the corresponding class is called as the median class. I will explain this with one example. See here the example. Calculate the median for following data, class interval and frequencies given. This is grouped data or the continuous data here. So first you have to get the cumulative frequency which is less than type. So first frequency write as it is, then add next frequency to this. 5 plus 3 8, 7 plus 8 15, 15 plus 9 24, 24 plus 4 28. So sum of frequencies is equal to 28. Now you have to first find out the median class. So to find median class, you need now n by tooth cumulative frequency value, which is equal to 28 by 2, which is equal to 40. So where the cumulative frequency 14 comes in the cumulative frequency column, you have to check. There is no 14 in the cumulative frequency column, but up to from 8 to 15 it comes under this. So up to 3 it is in this first value, next up to 8 here, then up to 15 here, so 14 is included within this. Hence the class interval corresponding to this cumulative frequency is called as the median class. This is how we calculate the median class. Find out n by 2, which is equal to 14, the cumulative frequency. It is cumulative frequency. See the cumulative frequency column where this cumulative frequency falls. This falls within 15. So the corresponding class interval is called as the median class. Once you obtain the median class, all these you have to find out. L means the lower limit of the median class, which is 20, because 20 to 30 lower limit is 20. C means cumulative frequency just preceding the median class. Cumulative frequency just before the median class, that is this, just before the median class. So C equal to 8. F means frequency of the median class. You have to see this column, that is 7. Then H means width of the median class. With this obtained, you finding low upper limit minus lower limit. 30 minus 20, that gives you 10. Then substitute these values in the formula. L means 20 plus n by 2 means 40 minus C is 8 divided by 7 into H is 10. So let us simplify this. 20 plus 6 by 7 into 10. This is equal to, when you simplify all these values, you will get the value as 28.57. This is the median for the group data. Now, one more measure of central tendency is mode. Mode means most repeated value in the given data, or you can call it as highest frequent observation. See, if you have the discrete data without frequencies, then you have to find out which value is most repeated, that is mode. See, for example, in the above data, this data, 2 is repeated 2 times, then 3 is once, 4 is once, which is repeated most number of times. 7 is repeated 4 times, therefore the mode equal to 7. If you have discrete data with the frequencies, then you have to check the data value with the highest frequency. Even if you write the same data as a frequency distributed data, then x2, then frequency 2 is repeated 2 times, 3 is repeated once, 4 is repeated once, 7 is repeated 4 times, then 9 is repeated once, 10 once, 12 twice. So the same data is now transferred to frequency distribution. So if the data is given like this, then data value with the highest frequency. So highest frequency here it is 4, the data value is 7, so mode equal to 7. How to find mode for group data, that is continuous data. Mo equal to, this is how we denote the mode, L plus f1 minus f0 by 2f1 minus f0 minus f2 into h. This is the formula to calculate the mode. So the terms of this formula are explained here. L is lower limit of modal class, F1 is frequency of modal class, F0 is frequency of pre-modal class, F2 is frequency of post-modal class, H is the width of the modal class. How to find the modal class? Class which has maximum frequency is called as modal class. See, for example, this is the given data, class interval frequency. First, let us find out the modal class. Class with the highest frequency. Highest frequency is 9 here. So, this class interval, that is 30 to 40, is called as modal class. Once you obtain the modal class, all these terms could be defined easily. L means lower limit of the modal class, which is 30. F1 means frequency of the modal class, that is 9. F0 is frequency of pre-modal class, that is class just before the modal class, that is pre-modal class, 20 to 30. This its frequency is 7. F2 is post-modal class, so that is 4. Then H is width of the modal class, 10, 40 minus 30, 10. Substitute all these in the formula. MO equal to 30 plus F1 minus F0, that is a 9 minus 7 divided by 2 into 9 minus F0 7 minus F2 4 into H is 10. That is equal to, let us simplify this, 30 plus 2 divided by 18 minus this value is 11, which is 7 into 10. So which gives you 30 plus this value is 2.85. So that is equal to 32.85. This is the mode for the given group data. Another measure of central tendency, that is another type of mean, is geometric mean. This mean is used when data is in multiplicative or exponential relationship. Most of the cases we use arithmetic mean. Geometric mean and harmonic mean are less used because geometric mean data values must be positive and non-zero. If you have any zero data value, then as per the geometric mean, that becomes equal to 0, because in geometric mean, instead of the sum, we use the product of data values. This geometric mean is used by an investor to measure the performance of investment in an investment portfolio. Now, how to calculate the geometric mean? For discrete data without frequencies, geometric mean is product of the observation to the power 1 by n. That is nth root of a product of observations. Instead of sum of observations, here we use product of observations. If you have discrete data with the frequency, then geometric mean equal to x1 power f1 into x2 power f2, so on up to xn power fn to the power 1 by n, where n is the sum of frequencies, total frequency. So the same formula can be written in terms of antilog. Geometric mean equal to antilog of summation of log of xi divided by number of observations, n. Log means it is log to the base 10, and antilog means you can take it as 10 to the power this value. This is used when you have more number of observations, because to the power 1 by n it becomes huge to calculate to the power of 1 by n. So in that case we use the geometric mean. So same formula for group data also, that is for class intervals we use this formula itself to calculate the geometric mean, which is antilog of summation fi into log xi divided by n. Instead of this formula you can use this in terms of log. See one example, find geometric mean of 2, 4, 8. geometric mean equal to cube root of 2 into 4 into 8. So which is equal to 64 to the power 1 by 3, which is equal to 4 to the power 3 to the power 1 by 3, that is equal to 4. So geometric mean of these three numbers is equal to 4. See second problem, calculate geometric mean of this data. A class and frequency given. This is continuous data or grouped data. Therefore, the formula to find out geometric mean equal to anti-log of summation of fi into log xi I equal to 1 to n divided by capital N, where n is the sum of frequencies. So I need one more column here. So that is frequency is fi. Then I need xi is the midpoint of this class interval. So this is the midpoint. Then I need fi into log xi. So log xi, then fi into log of xi. So midpoint is 5, 15, 25, 35 and 45. Then log of xi is log of 5. Here to the base 10 it is. So use scientific calculator to find out log of 5 to the base 10 or log table. So log of 5 to the base 10 value is 0.6990. Next log of 15 to the base 10. So that is 1.1761. Then log of 25 to the base 10, 1.3979. Then log of 35 to the base 10, 1.5441. Then log of 45 to the base 10, 1.6532. Then we have to find out fi into log xi. So this fi into this value. 3 into 0.6990. So that gives you 2.0970, 5.805. Then this value 9.7853. I have already calculated these values. I am writing directly. So 1.544 into 9, that gives you 13.8969. Then this value it gives you 6.6128. Now I need the sum of all this. That sum equal to 38.2772725. Then this is equal to sum of all the frequencies equal to 28. So anti-log of 38.2725 divided by total frequency is 28. Anti-log means 10 to the power this value. So 10 to the power this 1.3669, which gives you 23.28. This is how to calculate the geometric mean when you have grouped data. So one more formula for grouped data is x1 into to the power f1, x2 to the power f2, so on up to xn to the power fn whole to the power 1 by n. Using this formula also you can find out the geometric mean. Here it is 5 to the power 3 into 15 to the power 5 into, then this midpoint 25 to the power 7, then 35 to the power 9, 45 to the power 4. It gives you large number, then to the power 1 by 28. So instead of that, using this formula, calculation becomes easier. The last type of mean is harmonic mean. It is used when we want to average units such as speed, rates, and ratios. This mean would be appropriate. Most of the time we use arithmetic mean. In rare cases, we use a geometric mean and harmonic mean. Geometric mean is used when you have to find out the returns in investments, and harmonic mean is used when you have to find average units such as speed, rates, and ratios. Now let us see how to find out the harmonic mean. For a discrete data, harmonic mean equal to n by summation I equal to 1 to n, 1 by xi, reciprocal of the data values, then n by sum of reciprocals of data values. If discrete data is given with the frequencies, then harmonic mean is n divided by summation of fi by xi, where frequency is given. If you have grouped data, that is continuous data, in that case also this formula itself is used. Let us take one example. Calculate harmonic mean of 2, 4, 6. So harmonic mean equal to, there are three observations divided by sum of reciprocals of these observations. That's 1 by 2 plus 1 by 4 plus 1 by 6. So which is equal to 3 divided by 12 here. So this value 6 plus 3, 9, 9 plus 2, 11. So that gives you 36 by 11, which is equal to approximately 3.27. Now see second problem, calculate harmonic mean for this grouped data. The formula is harmonic mean equal to capital N divided by summation of fi by xi I equal to 1 to n. This is the formula to calculate harmonic mean. So I need total frequency n equal to 28. Then I need xi midpoint, that is 5, 15, 25, 35 and 45. Then I want fi by xi, fi by xi, that is 5 divided by, so fi is 3 by 5, this value I have to find out, 0.6, 5 by 15, 0.33, then 7 by 25, that gives you 0.28, then 9 by 35, that gives you 0.257, that gives you 0.257, then 4 by 45.088. Now I need the sum of all this fi by xi, so that is 1.55555. So harmonic mean equal to 28 divided by 1.555, which is equal to 17.956. So this is how we calculate harmonic mean for grouped data.